Good evening, everyone. I will start the class in a minute. Just wait a bit. Okay, let's start today's interactive session. So, welcome to the building materials and composites problem solving session week number 4. So, I am Purvita and I'll be taking this class. So this class is happening this is the fourth week. This interactive session is happening every Tuesday from 6 p.m. to 7 p.m. And we solve a few questions in this particular session. So if you have any kind of doubt, either you can raise your hand and unmute, or you can post it in the chat box. So let's see what we had already for week number 4. So week number 4 was about concrete. Module 4 was about concrete, where we learned about concrete, basic introduction to concrete in lecture 16. Lecture 17, we were taught about fine aggregates. Lecture 18 was about coarse aggregates. Lecture 19 was about cement, and lecture 20 was about water, plasticizer, admixtures, and different types of tests that are involved in the manufacturing process of this concrete. So today, what are we going to do in this session? So we will be focusing on few theoretical questions and some numerical questions as well. So here comes our first question. We'll start off with we'll try to follow the lecture modules, the sequence. So let's see, and I would ask you all to, or rather request you all to try to answer these questions. And Okay, so the first question is the step by step procedure of making concrete is. So you have got four options that involves batching or mixing or transporting and then compacting, placing the concrete, curing it. So what do you think would be the correct sequence of this particular question? Yes, any answer from any one of you?
Ma'am D.
Okay, so you are saying batching, mixing, then transporting, placing, compacting, and
And
curing.
curing. Yeah, right, D.
Okay. I hope, yeah, screen is visible. Yes, absolutely correct. Harsha, Nagma. The correct sequence is batching, mixing, transporting, placing, compacting, and curing. So if you look in this particular image, you'll see that batching, the first stage is batching. We had also learned when we were doing our module on glasses, that batching means that the raw materials are mixed in, or rather the raw materials are taken in proportion, and then just a second, yeah, and then just this is the next question is showing. I'll just explain the previous question. Yeah, now it's coming. So we can see that batching is all about taking the raw materials in proportion and then mixing. We have seen that there are different methods of mixing. It can be hand mixing, it can be with the help of a machine, it can be with the help of ready mix also. Then the mixing is transported to the place where it needs to be casted. So this, you can see the things are being transported, And then we see the next step is compacting. So compacting is a very necessary step. Here also we have learnt about two types of compacting. One was the manual type, right? And the other was the using vibrator. So using these two methods, we can compact the concrete that we are placing, or rather we are casting. Also, there was another step involved which is not mentioned here, that is placing. Because after transporting, what comes is placing, and with the help of frameworks or shutter works, we can place the concrete in the place, right? And then after compacting, the concrete needs to be cured for 28 days or 4 weeks so that it can gain its appropriate strength, and then finally we can do the finishing on top of it. Okay, so this is the sequence of basically the step by step procedure of making concrete. Okay, so we will move to our next question. Let it get just a second. I hope, yeah. Yes, now it's showing. So it says that match the vibrator types in group 1 with their related areas of application in group 2. I know this particular vibrator was not exactly like we just read about vibrator, but not the different types of vibrator. So that is why today we are here. That let's learn something new within the things that were also taught. So we will see how there are different types of vibrator, and you all can try because you all understand what concrete pavement is. So it's suppose you are doing a concrete road. Okay, so maybe what type of
C.
vibrator.
Okay.
Okay, Gauri says option C. Okay, if I get any more answer, or else I'll just go to my this particular thing. So it says answer is B, P3Q4R1S2. So what does it mean? So needle vibrator is basically used for beam column conjunction. Q4, which means shutter vibrator, is used for when we are making retaining wall. R1 surface vibrator. This particular thing is used when we are making concrete pavement. And table vibrator is something which is used when we are making precast concrete units. Okay, so this will be the correct answer. Now let us see with the help of some images whether we are being able to understand like what these vibrators, how these vibrators look, okay, and how their application are. So basically, when we talk about vibration, this compaction method of compaction, we do this either manually or with the help of vibrators. So this thing is something we all know by now, right? Manually or using vibrators, right? Now, these vibrators, obviously, you can understand when do we need these vibrators. The basic need of compaction is to reduce the air content in the concrete, because we have seen that even for 5 to 8% of voids, how much the this entire strength can reduce. So with that particular concept, we have to understand that compaction is necessary, and for that reason we can do either manual compaction or using vibrators. Now if we do manual compaction, that is fine, but that is applicable, or that can be done easily when we are when the scale is small. Okay, when we are compacting for a smaller scale. But just imagine the kind of high rises we are seeing, just imagine the kind of projects, the big projects we are seeing. So in that kind of projects, it's not possible to manually go and compact the concrete. It's very tedious. For that reason, these different types of vibrators are required. Now just imagine the different there are different surfaces, different types of surfaces. So for each of these surfaces, and even the scales are also different for each of the if we look at the vast application of concrete, you will see that it's not just about when we are using concrete in case of building in while we are constructing different buildings. It's also when we are making roads. We have also learned about when we were studying, I guess it was in the very initial this maybe the first module, if I remember. So it was then when we were talking, when ma'am was talking about this precast, units. So this precasting is something which is very useful. We will see at the end of the class. I'll show you one particular thing, or rather an example where we'll see that precast concretes how it has been used and how it helps. So precast things helps in in a very rapid construction. So all these things are there. So for each of the things, the compaction method needs to be different also. So and also in order to avoid segregation and bleeding means basically where the water segregates from the rest of the concrete and it flows. So that is what bleeding is all about. So we need to eliminate all these things, and that is why we need vibrators. Now look into this particular first image. Look into the first image where this needle vibrator is being used to compact the concrete in this beam and column junction, or maybe in this particular thing. So you can see this particular long something, this the machine is having something long thing. So that basically shows that it's the needle vibrator. Then if you look into the shutter vibrator, so these are basically the machines, the vibrators, okay. And the shutters are being casted, and the procedure is such that the vibrators will be placed, and the the things are can be casted with the help of this particular equipment. So if you look into the next one, so this is the surface vibrator. So we were talking, for we use this surface vibrator when we are making concrete pavements. Not only concrete pavements, but also when we have a very a long or a huge flat surface, and there we can use for that, for those purpose also. And there we are casting the concrete. There also we can use this particular surface vibrator. And another thing is this stable vibrator. So were also talking of this precast units. So when we are manufacturing precast units, this stable vibrators, because we know the dimension of the precast units. What happens for precast units? They are it is help for making modular units, and it has got some particular dimension. So you can build your table. The table vibrator, the size of the table can be made in that particular dimension only, and accordingly you can compact your concrete. So this is another example which is known as stable vibrator. Okay. So now let's move to our, I hope the things were clear to you all, and let's move to question number 3, which says that match the nominal mix for the following grades of concrete, where we have M15, M20, M30 and M40. Also we need to there are of course we have got our list, but also we need to remember, it's good that we, as if you all are coming from construction industry like background, maybe architects, maybe engineers, civil engineers, anything. So it's better that we all remember the grade and the ratio of the mix. Okay, so I get two contrasting answers. One,
B.
yeah, one is B, another is A. Nagmas is saying A.
B. B.
Okay, I get a
D, man. D. You.
okay. Most of you are saying B, although Nagma said
B. B.
A.
B. It's
Yes, yes, absolutely correct, Nagma. So if we look into this particular P, what it is, so it's 1 is to 2 is to 4, and then M20 is obviously here the question was easier, or rather you could even if you don't know, you can make things. I mean, you can at least understand, because the M15, when I say M15 or M10 even, that will have the highest, cement always remains 1. But when it comes to the ratio of, fine aggregate is to coarse aggregate, if you look, as we move, like the strength, as the strength increases, okay, so this, I explain what this M15.
This was easy to guess, ma'am.
Yes, absolutely. So if you, yeah, it would have been maybe tough if I would have, no, not tough actually. This anyways would have been easier, because ultimately we are having M15, M20, M30, and M40. And if you look into the ratio, how it decreases. So what happens? Cement always remains one portion only. However, the fine, if this is 4, so for 20 or for the subsequent numbers like 20, 30, 40, whatever it is. So this proportion of fine aggregate with respect to cement reduces. So that only, for like for M20 also, if you see, it's 1.5, and then the double of this fine aggregate is generally the value of coarse aggregate, which is 3. So you can remember in that way also. Okay. So, okay, next question is, so we are saying M20, M25, all these things, but what does this about? I hope you all have not seen the answer. The compressive strength of M20 or M25, whatever be it, here the question is about M25 concrete. What will be? Okay, I see answers B. Yeah, that is absolutely correct. So it's 25 Newton per square millimeter. Okay, so always remember that it is or not 25 always. So the unit will be Newton per nm square. So this is the thing, important thing that you all need to remember. Okay. So now I'll come to what this concrete mix is. So by now I think you can understand when I say concrete mix, it is about the proportion of how, like what in what proportion we are mixing the cement, fine aggregates, and coarse aggregates, and along with that we also add water to it. Okay, also for the water, when we are adding water, there are desirable proportion of water as well. So also when we get, when we talk about this, this mix ratios, so this mix ratios, how do we decide it? So it depends upon the type of construction we are doing. Suppose we are doing a particular type of construction which doesn't require much strength, and maybe the casting is done in such a place that it will not be exposed to heavy load or pressure. Okay, so in that case we can go for leaner or low strength mix, nominal mix, for example M10 maybe or M15 maybe. But something we are doing which requires high strength, then what we will do, then we will do this M30, M35, this range. Okay, also we can refer to IS 456 2000. So this particular IS code, this is a particular code that all the engineers almost they know. So this code basically talks about all these different grades and how we calculate this strength, that is also given. So you can always refer back. And also this particular strength, the compressive strength that it is achieving, it is the strength that it is achieving, this particular concrete is achieving after it is cured properly, that is after 28 days or 4 weeks. Okay, so this is what concrete mix is all about. Okay. So let's move to our next question, which says that reinforcements are added to concrete because.
B.
Okay, again this answer. Okay, Ali says A. Right. I'm not saying the answer is right or wrong. I'm saying I got another answer. Okay, so let me show you the answer. Obviously, the correct answer is B, because reinforcements provide tensile strength to the concrete. So what are these reinforcements? So reinforcements, as you can see, this can be in the form of this iron mesh. It can be in the form of these rods that you can see. So it can be in the form of anything. However, this steel bars or this mesh, these things are embedded within the concrete at the time of casting. Okay, so why these things are reinforcements are given? So obviously the first thing is that it will provide strength. But when we say it will provide strength, what kind of strength, that is also important for us to understand. So it can be either it is providing compressive strength, or maybe it is providing tensile strength, or maybe any other kind of strength. So what it is, so we should always remember that concrete is, it has a good amount of compressive strength within itself. However, it doesn't have much of, or it rather cannot resist much of the tensile load. So these reinforcements are provided. So this extra additional, this concrete needs additional strength. Otherwise, what will happen? There will be cracking and it will break. Okay, which will lead to like breaking. So, if this particular tensile strength is not provided to the concrete by any means, okay, so the easiest way is definitely to provide this, additional. In order to provide this additional strength, is the is the embedding of different steel bars of different cross sections. So, the steel bars that we use, or the quantity of steel that we are using, or the kind of yes, rather the reinforcements we are using, this can also be designed. Okay, like what quantity of steel should be used, also the strength of steel bars are different. Okay, so according to that, we generally, when we design, we assume that okay, this particular, maybe we can assume for a particular neutral tensile strength is provided by that steel bar. But however, we can always design that how many number of rods will be required, the steel bars will be required, what will be the cross section of each of the steel bars. And not only that, when we are inserting this reinforcement bars, this when we are basically cast, before the casting of concrete, it should be taken care that this reinforcement bars don't move from from the place. For that reason, this tie bars are also provided. So if you look at from the plan, it looks like this. Okay, so the things are tied like this. And if you look from the elevation, it looks something like this. I think a lot of us have seen also. So it looks like this. So the rods are, reinforcement bars are once again tied with thinner metal strips. Okay. So I think the reinforcements, why these reinforcements are required and what is the role of reinforcement, I think this particular thing is like understood by all of you. Now let's see one small numerical. It's not very difficult. So what does it say? So it says that suppose the height of bulk sand in container is 10 centimeter. Okay. So now that means we are talking of bulking of sand. Okay. Since I'm telling bulk sand. Now it says that there is a container where we are trying to understand what percentage of sand is bulked, or the bulking of sand in percentage. So, what is bulking? Let me just give you this. I hope you all have gone through the module, but still, bulking of sand is basically when the sand, it has moisture in it. So that is known as bulking of sand. And when this happens, bulking happens, then what happens? The overall volume of the sand increases. And as a matter of fact, when we are doing this, when we are doing batching, the first step of making concrete, in that scenario, what will happen? If the volume of sand increases, but that volume is increased by the moisture and not the actual quantity of sand, then what will happen? The overall concrete that we will manufacture ultimately, or that we will make, the overall volume of that particular concrete will also decrease. And there are certain percentages, if we look into, like for x amount of bulking of sand, a significant amount of, there will be a reduction in the quantity of concrete that is produced. So these things are not desirable, because from the beginning only we can understand that this mix, nominal mix, the mix of this different materials, raw materials, this is very important, because you can see how change of proportion can change the strength that is ultimately gained. Okay, so here comes the necessity that we understand that in a sample of by taking a sample of sand, that what is the actual bulking quantity, and accordingly how much extra sand should be taken, so that the overall quantity of concrete, when it is ultimately the fresh concrete that we get, is that the volume of that particular fresh concrete is not reduced. Okay, so this is important. For that reason, we will do this particular numerical. And here what it is saying that the height of bulk sand is 10 centimeter and the height difference of saturated sand and bulk sand in a container is 2 centimeter. Find the bulking of sand in percentage. Yes, can I mean, if you all want to try, you can. Else, obviously, I'll show the answer. Okay, so how are we getting it? So the answer is 20%, but yes, how are we getting it? So so basically this will describe the process, like how you can check the percentage of bulking of sand, right? So here it shows that there are two containers, one containing the bulk sand. So bulk sand we have got a particular height which is demarcated as H. Okay, and then what happens? The similar amount of water is actually taken. Water in another container, and this sand, the bulk sand, is mixed in that particular, here you can see this is just I don't know whether it's visible or not. So this is the water level, and what happens if you keep on stirring the bulk sand into the other container? Okay, so the sand will get saturated and it will start settling down. So this is what happens. And once the sand gets or starts, or rather it starts settling down, what will happen? You will get the actual height or the actual, quantity of sand that is present. So it's no more just the bulk sand. It's basically the saturated sand that has settled down, and the remaining half you will have the water. Okay, this is the water. So this is how you can basically understand, or rather you can, this process will help in understanding what percentage of bulking is there. Now if you consider this particular height to be small h, or there can be different notations or representations also. For example, if you consider this one as h1 and this entire height to be h2, then h2, or rather h1 minus h2, will give you the value of h, that is equal to h. So okay, so that's not the issue. It's just understand which height we need to understand. So just consider this particular, level difference of the height. And now what we will do, in order to find the bulking of sand in percentage, we will simply take this small h divided with the bigger h. The This height is the bigger h, and then since we have to find out the percentage, we will multiply it with 100. So here what did we have? So here we already had that the difference, this difference, see the height difference of saturated sand and the bulk sand. I hope now you all are able to understand what I mean by saturated sand. So the saturated sand and the bulk sand, the difference, this is the bulk sand, so the difference is small h, and we are considering the total height divided by bigger H into, or capital H into 100. So 2 by 10 into 100, so this is giving you 20%. So how much of the percentage of bulking this particular sand already had? It is 20%. Okay, so this is how we calculate. Also, when talking about this bulking of sand, okay, this is showing the this change. I don't know why it doesn't sync with the thing which I keep on changing. Uh, just a second, give me a bit time. It takes, sometimes it takes time. I'm not getting the desired slide that I want to show. Other than that, the previous slide and the next slide is coming. Anyways, I'll just talk of bulking of sand. You all can hear, and once this class is over, you can always refer back to the PPT. So basically, I have this particular this yeah, now it's coming. So this here it talks about what is bulking of sand. So by now you understand that when sand comes in contact with the moisture, a particular thin layer of water is formed around this sand particles, and that basically leads to the bulking. Why bulking? The term bulking, because it increases the overall volume of the sand. So due to this presence of moisture, and that is why we call it sand bulking, or rather bulking of sand, whichever you want to say. Now this bulk sand, it consumes, since it consumes more volume because of the presence of water. So if we do a volumetric measuring of while we are doing this batching, then what will happen? For proportioning of concrete, we will get wrong measurement. That is why bulking correction is necessary. And also in our in our lecture module, we have seen that fine graded sands, it bulks the most, whereas the coarse graded sand, it bulks the least. Okay. And also, if you look into the percentage of moisture added, like how did we find, or how could we understand that, okay, from saturated sand, we can get the actual bulking of the percentage of bulking of the sand. Because if we look at the characteristic of this particular graph, and if you try to understand the characteristic of the sand, you will see that bulking happens. Okay. But after a certain point of time, if you keep on adding moisture, the bulking removes. And ultimately, what you will get? You will get this part. If you look into this part portion of the graph, you will see that you are actually leading towards saturated sand. Whereas till almost this part of the graph, you are into the bulking phase. Okay, I hope this thing is clear to you all, bulking of sand and how we can find it out. Okay. So now coming to our next question, the seventh question, which is about the fineness modulus of 1 kilogram sample of sand having the following reading. So following reading is this one. When passed through the sieve is given. So it says that diameter of the sieve in one side, so it's 4.75 mm. So the weight of sand which is retained, so this is basically how much of the sand it is retained. Okay, is 0. 2.36 has 100 grams, 1.18 mm diameter has 300, next one has 200, next one has 300, and then 0.15 mm has got 100 mm of, sorry, 100 grams of sand retained in it. So let us try doing this particular numerical. If you all can give me the answer, then of course it's very good. So I'll just show you how to do it. So, what is this fineness modulus of sand, or fineness modulus of aggregates? Okay, so we have seen that there we calculated fineness in the modules, the lecture modules. We have seen that how fineness modulus is calculated for both fine aggregates and coarse aggregates. So this is basically the empirical figure which is obtained by adding the total percentage of the sample of sand retained on each of the sieves, the sieve sizes that you have seen. So the basically what percentage of this sand is retained, and then dividing it by 100. So we will get a particular value, and accordingly we can understand that what is the fineness modulus. And we have seen how we can there are particular ranges. If the fineness modulus falls within that particular range, we may call it as a fine sand, we may call it as the medium graded sand, or we may call it as the coarse graded sand. And we have also seen that for construction purposes, medium graded sand is most preferred. Okay. So how do we find this particular thing? So just see, you can do it with along with me also. I also have the thing done in the next slide, but let's see what does it say. So 4.75 has 0. Okay, so 0, then okay, Tubaya has already find the answer. Oh, yeah, 100, 300, 300, and again 100. So, and the other side we have got the sieve diameters. Okay, sieve dia starting from 4.75 mm to 0.15 mm. Right, and this is the total quantity in grams, the quantity of sand that is retained. So obviously it's said that 1 kg, so it will be 1000 gram. So this is done. Now what we will find out? We will find out the cumulative amount of the cumulative quantity of sand that is retained. So how do we find out? So here it will be 0 only. I'll just draw the lines. Yes. Apart from Tubaya, anyone else who could do this? Okay. So cumulative means what? We will add the previous one. Is okay. We will add the previous weight with the weight of this particular one. Okay. So 100 plus 0 is obviously 0 only. So this is equal to, sorry, not 0. I mean 100 plus 0 is equal to 100. Now we will add 100 with this one. So 100 plus 300 will give you 400. Then 400 plus 200 will give you 600. 600 plus 300 will give you 900. And obviously for the last column, for the 0.15 mm, it's the remaining one. So what will be the remaining quantity? It will be obviously 1000. So 900 plus 100, once again it's 1000 only. Now we will find the percentage of cumulative weight retained. Okay. So 0 of 1000. How much? We'll get 0 only. Now 100 on, 100 grams of the 1000 grams. So how much do we get? It's obviously 10%. So 400 grams of 1000 grams. We have 40%. Next we have 60%. Next we have 90%. And next 1000 of 1000 grams. That means we have 100%. And if we just give me a second, yes. And if we add all this, how much are we getting? 40, 50, this one is 300. Okay, so we are getting the value 300. Now how can we find the fineness modulus? This, that thing is only given. So fineness modulus is equal to, so here what it is said, by adding the total percentage of the sample of a sand retained on each of the specified series. So this is the cumulative value. So 300 and dividing the sum by 100. So that is equal to 3. So this is how we get the value or the answer 3. So same way you can do it for coarse aggregates also. So for coarse aggregates you will have some more sieve sizes on the upper side, because we know anything which is above the diameter of 4.75 mm is considered as coarse aggregate, and also it should be within 40 mm preferably the diameter. So that includes, so obviously you can understand the sieve sizes or the sieve analysis when you will do. So it will have much more layers added to it, and accordingly, or rather the size, the limit will be on the higher side. So accordingly we can calculate for the coarse aggregates also. But the method remains the same. Okay. So yes, Tubaya, your answer was correct. It's option C, which is 3. Okay, so this is just the solution of the same thing that I just did. You can always refer back to this one. Okay, now coming to our eighth question, which says that match the following shapes of coarse aggregate in group 1. This is group 1 with their corresponding disadvantages in group 2, and this is group 2. Yeah, sorry, this is group 2. Yeah. Okay, Harsha says 3. I guess the answer she says is this one. Yeah. Let me see. So rounded, we have irregular, and we have flaky aggregates. So each of this aggregates, let me just see the answer. Yes, absolutely correct, Harsha. It's third option. This one. So P3, which means that basically rounded aggregates have the tendency to segregate. Why? Because sorry, P2, because rounded aggregates they cause bond failure, because they are shaped like this, and as a matter of fact, what happens? The interlocking does not happens amongst the coarse aggregates, along with the binder that we are using. So binder can be anything, it can be cement, it can be lime, but here since we are talking of concrete, cement concrete, so we will consider that cement is the binder material. So there can be bond failure due to this lack of interlocking. Then we have irregular aggregates. So irregular aggregates are better, but however, due to the presence of different faces or different surfaces, or many surfaces rather, it requires more mortar. And there can be flaky aggregates also. So flaky aggregates are something like this. So flaky aggregates, what will happen, they also have this tendency to segregate. So that is, these are some of the this disadvantages. However, we prefer to use angular coarse aggregates. So these are better. These also have got some kind of disadvantages also, but yes, it's least than the other types. So here, so what are these coarse aggregates? So they are basically the small shaped, this stones which lies within a range of 4.75 mm to sorry 40 mm, and also there can be different types according to their shapes. For example, rounded, angular, irregular, or flaky. Also, they are different types of aggregates can be there according to their weight. There can be lightweight aggregate. There can be heavyweight aggregate. Also, we have studied that as per their sizes, the requirements are also how flaky aggregates segregate. So basically, they have the flaky aggregates. How they, if you look into the flaky aggregates, so they are something like this. They are thin pieces like this. The width, or rather the thickness, is very less. Okay, and they have this longer length and shorter width. And as a matter of fact, when they are mixed, it either it breaks, it segregates, or it leads to the segregation of the concrete itself. Okay, because of poor structure, you can say. So that is why flaky aggregates are not preferred when we are if our desired concrete needs to have higher strength. Because this angular shapes, the shapes they have, most of the aggregates, they have got proper, not proper at least, but yes, better, like better cuts. And as a matter of fact, the interlocking is properly done. Also, it requires optimum amount of concrete, or the binding mortar is required. So that is not concrete, but the mortar that we are talking of. So that is why this angular concretes are or sorry, angular aggregates are preferred. Yes, as I was just talking about the different shapes of the aggregates. So depending upon the different shapes of the aggregate, we have seen that also they are used in different places. Okay, so for bridges we use maybe this particles which are near about this 40 mm. There are different uses for aggregates which are 20 mm size, and then lesser diameter are used for clear cover. That also we have seen in our particular uh, video lecture. So coming to our, so I hope this once again this thing is clear. And coming to our next question, which says that match the following types of cement compounds in group one. Once again, this is group one. I'll add the group one things, right? And this is group two. Yeah, with their corresponding uses in group two. Okay, I got one answer. Harsha saying P1. Okay, let me see. I'll just mark it. If anyone has got any other answer, probably P. I mean, option A or the first option is not the correct answer. Yes, it's the fourth option which is correct, because if we see C3S tricalcium sulfate, so this basically this basically provides the strength, right? In the initial strength in the first way, And then if we talk about, I understand you just confused this one with this one. So this is quite, obvious. Because even I make this particular mistake, but it's, don't worry about that. Next is C2S. Yes, Harsh. So the next is C2S, which basically provides strength to the concrete beyond first week. Okay. So just be careful with C3S and C2S. Apart from that, if we look into C3A, so it helps in stiffening of the concrete, and also, once gypsum is added, obviously gypsum is, it helps in retarding the setting time. And then we have C4A. So this C4A for tetracalcium aluminiferrate, this basically helps to bring down the temperature while manufacturing. It has also got another use, that is it adds color to the concrete due to the presence of ferrous material, or ferrous, or fer- this ferrous. Okay, so this particular element ferrous, this gives color to the concrete. Okay. So yes, this is just an explanation where it says that Portland cement is made up of these four compounds: tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminiferrite. And these are basically, abbreviated into this C3S, C2S, C3A, and C4A. So these things we already know. And C stands for calcium oxide, that is the lime content that is present in cement. S stands for the silica, the silicate that we have, the compounds forming silicates. And A is for alumina, and F is for iron oxide, or the ferrous presence. Okay, so that is how these things are abbreviated. Coming to our next question, which says that match the following types of tests in group 1. Once again, I'll just write it. With their corresponding uses, or with their, with their corresponding uses in group 2. So we have wicket test, we have slump test, we have cube test. So we got one answer, that is C. Uh, yeah, that's the correct answer. So VCAT test or VCAT apparatus, yes, Varshini, correct. So VCAT test is basically with the help of using with the using this VCAT apparatus. So this VCAT apparatus is used to measure the setting time of concrete, and also you might find there are different questions, or there are different times when it's about or finding the consistency. This is also, like, you can alternatively see that Beckett's test or Beckett's apparatus is used to find the consistency of the concrete, or in order to measure the setting time of the concrete. Next, we have slump test. Slump test, we know that it's used to measure the workability of the concrete, and the cube test is used to measure the compressive strength of the cured concrete. There's also actually a method, or a test to measure the specific gravity of cement, which is known as, if I'm not wrong, it's known as picnometer. Picnometer, not test, yeah, I mean picnometer is used basically. That's an instrument. So picnometers are used to measure the specific gravity of this, but it can be used for measuring the specific gravity of cement. So if you look into the images here, so here you can see the VCAT apparatus, where you can see there's this one particular needle that goes, or the plunger. Okay, and the cement basically is kept, inside this container, and then it's checked that, how much or rather how much of the needle it has, gone inside for a certain period of time. So this values helps you to understand the consistency of this particular concrete that you have. Then we have slump test, where we use this kind of thing, the instrument, and we put inside the prepared fresh concrete, and then we slowly move this one. Of course, compaction is done with the help of a compaction rod, and also there's a certain procedure when we do slam test. So it's not that you put the entire concrete all at once. You put it in layers. Generally, it's if fill one third at first, then you compact it with the help of a rod, then you put the other one third, that is you fill the two third, you again compact it, and then you finally fill the last part, last one third, and then you further compact it, and then you slowly remove this particular this truncated thing, and then you check the height after you remove the truncated this particular thing, and basically you check the height of the slab. So the difference in this height will help you to understand to like what is the workability of that particular concrete. And then of course we have cube test. So a cube test is a dry test, or rather it's not with the fresh concrete, it's with the cured concrete. So it's the concrete which we get after 28 days, and then in order to check that strength of that particular the concrete sample, pressure is given, and the pressure at which the cube basically breaks. So that particular just the the level just before that particular thing is recorded, and accordingly you can say that what is the what is the compressive strength of that particular sample of concrete. There are different other tests also when we talk of concrete. So one of them being the hammer rebound test. So it also helps in checking the strength of the concrete. However, it's a non-destructive test. That is for the cube test. What did you see? The cube is destructive. However, using this rebound hammer test, we can check the strength, but at the same time, we are not destroying the concrete structure. So that is hammer rebound test. And also we have this Los Angeles apparatus which helps in finding the abrasion, or it's an abrasion test. Basically, what is the hardness of the surface of the this particular or gradings of the aggregates when it is subject to abrasion. All these things can be measured with the help of abrasion test, and Los Angeles apparatus helps you to do one. Okay. Now coming to our 11th question, which is superplasticizer is added in concrete mix 2, and you have got again four options: reduce the water cement ratio, increase the water cement ratio, reduce the flow, and reduce the content of coarse aggregate. I know you have learned about plasticizers. Related to plasticizers only, I'll give you the difference of basic difference of plasticizer and super plasticizer. I think from the name super only, you all are able to understand. So the basic use of this plasticizer is to reduce the water cement ratio for a, yes, absolutely correct, Gauri, for a particular workability, and that you can achieve with the help of adding plasticizers or super plasticizers. Now plasticizers and super plasticizers, they are both chemical compounds, and they both enable the production of concrete with the help of less water cement ratio. But only thing is that for plasticizers you get approximately 15% less water content. Okay, and for super plasticizers you can reduce the water content by 30% or more. So these are the two things, two differences of plasticizers and super plasticizers. So this also retard the curing of the concrete. Okay. Now moving to our last question, question number 12, which says that this is one particular numerical. It is a very small numerical. Also, those who are once again involved in the construction industry, you all have seen that how we need to find different. There are different questions where we have to estimate the number of cement bags. So this is also one such method. There can be different ways where here it says that 1400 kg of concrete. You can also get question where it is talking about it. This is weight batching. We can also get questions regarding volume batching also. But for this course or for this particular module, I think it's not required. But yes, if any one of you are interested, you can always go through it. And if you don't get, you can ask me also. I can also share some of the examples of numericals where we find out how many cement bags are required if we are preparing the concrete with the help of volume batching. This is weight batching, which is the easier version of calculating the cement bags. And it is also said that the mix is 1 is to 2 is to 4, and we have to find out the number of cement bags. So how do we find out? Any Gauri says 40. Is it? I think there's some mistake with the zero only. Just check it out. Otherwise, maybe you're going in the right direction. So basically, when we have this mix, one denotes cement, right? And the other denotes the aggregates. So here we are more, concerned about the quantity of cement. So here the quantity of cement is one proportion of 4 plus 2 plus 1, that is of 7 parts. So out of the entire 7 parts, one part is cement, right? Of which one? Of a 1400 kg concrete. So from here you will get, yes, got it. So here you will get, so you are basically using 200 kg of cement, right? So also we know that one bag of cement, the weight of one bag of cement is how much?
50. 50.
Yes, got it. 50
50.
kg. Yes, correct. So we just divide this 200 with 50 and we get the answer 4. So this is as simple as that. So this is how you can calculate for, and answer is hidden over here anyways. So this is how you can get the number of standard cement bags required if it's for weight batching. Okay, that was just the explanation. And yeah. Now moving to, like as we do for each of our classes, we try to see what are some of the buildings or some of the application of the material that we are studying. And today also we will see. So this is, can you all, anyone, this is, I can give a hint. So this is, I can say, the oldest construction with the help of
Parthenon.
uh, there are there is a
Pantheon
Parthenon. There is another thing. Yes, I think Rohit said something.
and Pantheon, Rome.
Pantheon, yes. Abhishek, I think your 50 answer, you are telling this about the numerical that we did. Ocha, 50 kg. Okay, now I got it. I thought you were giving the answer. Yes, yes, absolutely correct. So this was built something. I mean, of course, it has got a different history. I won't go into all those things. But if you look into the structure, so this was built and then it was set on fire and then it was destructed, and then again it was again built and all these things. And the timeline goes back to something around 125 or 26. I don't remember exactly, but yes, something around this time period. And it was actually the Romans who invented the Portland cement that we see today. So they were the first people to use cement, to understand that cement can be used as a binder, and then mixed cement with different aggregates, and they had built this particular dome. So this is one of the earliest example, and one of the largest construction of a concrete dome. So this is a very beautiful example of of the early or the initial application of concrete. Okay, so this is another very well-known example. I'll give you the background, or rather the story of it. and you can, if you all know the answer, I mean name of this building, then so it's good. So this particular this is basically a housing project, a housing complex, you can see. And if you look into the form, and it's very unique and it's very different. And here this precast concrete units have been used, and this entire this is just a part of the housing that you can see. And this is very well known. It's built by, or rather designed by, a very famous Moshe Safdie, Habitat 67 in Montreal. And this has got again a different, you can always go into the background and history and check whether it was successful. It was for mass housing project. Okay, so okay, so those two were from outside India, and this is one example from our very own Chandigarh, and this is known as the Palace of Assembly in the Chandigarh Capital Complex, which was designed by Le Corbusier during when the city of Chandigarh was being planned. And this is, and if you look into Le Corbusier's work, even B.V. Doshi, if you all are aware of B.V. Doshi, the Pritzker Prize winner of India, who got Pritzker Prize in 2018, and one of the stalwarts in the field of architecture and planning and designing, and his very own office, Stapati, if I'm not wrong. Sorry, Sangat. So Sangat is the name of his office. And so even his works, you can find different works. For example, the Tagore Hall of Ahmedabad. So those are all concrete buildings, where the exposed concrete is basically used. You won't find any color on top of the concrete. So here also the Palace of Assembly by Le Corbusier, or maybe this particular building, the Secretariat building, again in just a second. Yeah, the Secretariat building in Chandigarh Capital Complex. This is also another great example where this exposed concrete is used, and this is also designed by Le Corbusier. Okay, so you'll find there are numerous examples. You can always uh, go through them and revisit them. So that's all for today's session. Thank you for holding up. And if you all have any question, we can, or else we can call it a day. And once again, thank you for joining this session. I hope it was helpful. By Yeah, thank you, Harsha. Thank you, Aliu. Hope to see you all next class. Thanks, Rashmi. Thank you, Gauri. Okay, I'll end the meeting. Thanks, Abhishek. I'll end the meeting here. Good night, everyone.